Okay, so Boyle's gas law was the first one. The second one, the equation is about pressure and temperature. So we were dealing with pressure and volume. Now we're dealing with pressure and temperature. It's really a similar setup. You've got the original pressure and temperature on the left, the final pressure and temperature on the right, and make sure we're using absolute numbers. So we talked about absolute pressure already. You also need to use absolute temperature, which means we're using the Kelvin scale. So even though we use Celsius for a lot in this class, for this we need to make sure we're using Kelvin, not Celsius. And again, the problem will give you 3 of those values, and you solve for the 4th one. So let's look at a quick example of that. A quantity of gas has an absolute pressure of 165 kilopascals and an absolute temperature of 380 Kelvin. When the temperature of the gas is raised to 620 Kelvin, what's the new absolute pressure of the gas? So we have our starting pressure and our starting temperature, and we have our final temperature, and we're trying to find our final pressure. So we just put the numbers into this formula. So on the left, we have our starting temperature and pressure. Okay, 165 and 380. On the right, we leave this here because this is what we're trying to find. And then we have 620 as our ending temperature. So to solve for this PF, whenever we have formula set up like this, where we have a fraction equals a fraction, we could cross multiply. So if you remember that from math class, you're going to take the numbers diagonal from each other and multiply them. So this number times this number is equal to this number times this number. Okay, so it looks like this. So we take 620 times 165, and that gives us this big number, 102,300, and that's equal to 380 times the final pressure. Okay, so cross multiplying. Now that we have it set up this way, it's a little easier to solve. So we just take this big number divided by 380 and get our final answer of 269. All right, and one more practice question because again, we got to make sure we're using absolute units. So in this question, we have a pressure of 110 kilopascals, but a temperature in 45 degrees Celsius. So we need to change that to Kelvin. So to use that formula, we need to change it to Kelvin. And if you'll remember from the beginning of this lesson, to go from Celsius to Kelvin, you just add 273. So we take 45 plus 273. Oh, this came up out of order. I'm sorry. Okay, to get our starting temperature, we take 45 plus 273, and that's our new starting temperature. That's it in Kelvin. And our final temperature, 75 plus 273 gives us 348. Okay, so now we have those numbers. We could put those in for the temperatures, and we have our original pressure, which was 110. So 110 is our original pressure. 318 is our original temperature. We keep our final pressure as a variable because that's the new pressure, and our final temperature is 348. And again, we cross multiply. 348 times 110 gives us this number, and then 318 times final pressure, and then we solve for our final answer of 120. So again, I know it's a lot of math in this one. If you have any questions, definitely ask. If you want me to go over something again, definitely ask. And I'm just going to jump into the third gas law, but again, don't hesitate to ask questions. You're not going to interrupt. The third one is about volume and temperature. So we've done pressure and volume, pressure and temperature. Our third combination here is volume and temperature. So with this one, again, we're using absolute temperatures. So if you see Celsius, you have to convert it to Kelvin. And again, it's going to give us 3 of the options, and you solve for the 4th one. You can also use the formula for cubic expansion. So we're dealing with changes in temperature and how that changes volume. So you can also go back to that temperature and volume cubic expansion that we talked about at the very beginning. So we're going to look at an example that uses each of them. And when you're dealing with this formula, you've always got to know your coefficient, which is K. And for any gas, it is 0.003663. So this is probably another number that you should write down. The coefficient of cubic expansion is that for any gas. So here's a version using just the formula that we just got. So volume original and our original temperature and our final temperature, and we're trying to solve for volume. So we just put those numbers in, and it's just like the last ones we did. You cross multiply and you get your final answer. So if you could do the previous ones, this one's not too big of a deal. But our next practice question is actually one where your study guide actually tells you you should use the cubic expansion formula. So we'll look at that real quick. So a mass of gas under constant pressure has a starting volume of 0.40, temperature of 33, its ending temperature is 56. So those are three of the numbers we put in here: starting volume, our starting temperature, and our ending temperature. And then K is the number we just talked about. For cubic expansion, K is always this number for a gas. So with solids, it could be lots of different numbers. There's a table for it. With liquids, remember we got those three numbers before, and we said those are the only ones we'll need for liquids for this class. And for gas, it's always going to be that number. So we just plug those numbers into that formula. We have our original volume, our coefficient, our change in temperature. We do the parentheses first. 56 minus 33 is 23. We multiply it all together, and there's our answer of 0.336996. And remember, once again, this helps you find the change in volume. Lowercase v is the change in volume. So the question actually asks us what will be the new volume. So we have to add our change in volume to our original volume to get our new volume. All right, so we have one more review question before we end this. So which temperature is okay to use for the second gas law equation? So our options are 200 degrees Celsius, 473 Kelvin, and 392 Fahrenheit. Those are actually three different ways to say the exact same temperature, but which one do we use when we're talking about gas laws? So I'm going to stop talking so you can vote. And again, this is a good time to ask questions if you want them. And almost everyone voted. I'm going to give you another 10 seconds. I'd like to get that last vote in. All right, we got it, 100%. Awesome. Okay, so almost everybody got the right answer of 473 Kelvin. And this is the formula that we'd be using it in. So we have to put our temperatures in for the T's. We did get a couple answers of Celsius. So we do use Celsius a lot in this class, but when we're dealing with gas laws, we need to use absolute pressures and absolute temperatures, and Kelvin is the only absolute temperature. We did talk about that in lesson 2.1 if you want to go back and watch that video. Okay, so we had all three of those equations. They're kind of short. They kind of only deal with two variables at once. But in reality, pressure and volume and temperature change all at the same time. So we actually have this last mega formula. It's called the general gas law. And this combines all three things. We've got pressure and volume and temperature. And it still works exactly the same way though. You fill in all of the values except one, and then that's the one that you're solving for. So our very last thing is a practice problem with that, where we have got all three variables changing at once. So we have a volume to start, our starting volume, our original temperature, and our original pressure. So we put those in for this side of the formula, and then we have our new volume and our new temperature, and we're trying to find the new pressure. So that's what's on the right side of the formula. So we just plugged all of those numbers in the right places. Okay, our original pressure and volume and temperature, and our final volume and our final temperature, and then we're solving for PF. So it's a little more math because we've got some more things going on each side of the formula, but it's still set up the exact same way as the smaller formulas. So we could still cross multiply them. So we take 377 times everything over there, 770 times 3. So that's what we did here. And then we have 210 times PF times 7.5, and that's what we did over here. Except this should say 7.5. Sorry about that. Okay, and we just simplify. We multiply everything over here to get that, 870, 870, and we multiply over here to get this, and then we divide and get our final answer of 13. So I know it looks like a big scary formula, but it's exactly the same as the other ones. You just fill in all the values except one, you cross multiply, and you solve for that last value. So that brings us to the end. I know it was a lot of math. I can stick around for a bit if you want me to go over anything, if you want to go over any specific formula, any practice problem. We've got the time to do that, so I'll just stick around. I'm going to stop talking and give you time to ask questions. So you can ask about this, you can ask about anything else in the lesson. Now is your time to do that.